Okay, well, I'd now like to introduce today's presenter. Joel Olson is a operations manager at Microsoft supporting worldwide collaboration and knowledge management needs. In the past year, he's focused on architecture and design for Microsoft's intranet in a tight partnership with the SharePoint product groups as a technologist. Joel is now focused on optimizing a global SharePoint environment and providing product feedback for the next generation designs. And with that, Joel, it's all yours.
Thanks a lot, Jason. Welcome, everyone. I'm Joel Olson, technologist inside of Microsoft. And today we'll be talking about SharePoint performance, capacity planning, the best practices and lessons learned. And we're looking at it from an IT perspective, the Microsoft deployment of SharePoint. And we're looking at what we've learned, and hopefully there'll be lots of information that you'll be able to glean for your environment for those deployments you're either planning or either optimizing deployments you've already got and working with. So jumping right into it, I do assume that you know about SharePoint Portal Server, Windows SharePoint Services, and IIS. Some level of administration skills there. Now we're going to be drilling into SharePoint. I'm not going to be describing much about the product because we're really talking about how to optimize SharePoint. And it's going to be fairly technical. I'm not going to have any developer references really, but I am likely going to refer to tools and scripts that we've written or built. I'll be talking about some different things about our solution. And in a sense, what we're doing is we're capturing the best practices and lessons learned inside of Microsoft and kind of bundling them and walking across our solution, what we've done for capacity planning, some of those best practices, and some numbers that will really kind of help you in terms of your planning, how well that Microsoft has actually scaled running the solution and how we've done that, what it's like to manage the environment, and walking through each of the bottlenecks that we ran into and how we performance-tuned our environment to continue to scale out. Then I'll actually tell you about what's happening next year, what we're kind of on the edge of doing, and what we're actually looking into going into next fiscal year. And as well, I'm giving you references so that you can look and dig into further white papers in terms of our environment and others that the product group has published. I will be saving about 15 minutes at the end for question and answer. So let's talk about our solution. At Microsoft, it's a fairly complex environment. We're scaled across the globe where we've got users in over 83 countries, about 90,000 users from around the globe. It's really a fairly complex environment when you look at the number of users to the number of devices, basically around an average of 3 devices per user. And when you look at it from the SharePoint perspective, it's all these people need to be able to communicate. They're used to communicating via email, they're communicating via IM and instant messaging. They've got all sorts of connections and partners where they're needing to communicate across the globe. Our strategy has really been to take that somewhat complex environment and to provide a very consistent way of sharing documents and collaborating with users. And we found the best way to do that was to really fully adopt SharePoint as our strategy from the individual with personal sites all the way up through the division and into the enterprise where we can get search across all of that information as well as information in public folders and on file shares, legacy information and archives where a user can go to one place and get enterprise search. And the way we've done that inside of Microsoft is to really kind of build this hierarchy. MS Web is our corporate portal. It's where we wanted to provide the best enterprise search experience using SharePoint Portal Server 2003. As well, what we've done is we've worked with the divisions inside the company to kind of build this strata where they can actually consume search from MS Web. So rather than everybody searching their own information, and then getting MS Web coming behind them and searching that information, we're using shared services, one of the features of SharePoint Portal Server, to provide search to those portals. We're as well doing that for content management sites, like CMS sites, like our HR Web site, where we've got the the travel information, the handbook, different information where users are going to learn about their HR type needs. If you were to navigate to that site, you'd notice that the search there is actually coming from SharePoint Portal Server. So the divisions inside of Microsoft really kind of look to MS Web to provide that top-down approach where they provide search as well as navigation through a site directory to those sites. Groups and smaller regions and so forth, affiliates out in the regions, what they'll do is they'll actually dock to or associate to those divisions or associate to MS Web, where MS Web will provide search to that information across the globe. And what we've done is we've actually taken our deployment, and Redmond, which is the corporate headquarters, has the aggregated enterprise search. You can find anything across the globe by searching in Redmond. Of course, you have to have the rights because it is security trimmed, but we're indexing all SharePoint information in our other deployments. So what we've done is we've taken Redmond, which serves North and South America, Dublin, which serves Europe, Middle East, and Africa, Singapore serves the South Pacific and some of the Far East, and Shofu, which is a suburb of Tokyo, which serves Asia. And what we've done is we've done a deployment of SharePoint in each of those locations, and then we use our Redmond installation to index that. So in a sense, what we've done is we're hosting Windows SharePoint Services sites, personal sites, or my sites. We have a partner environment, which is basically extranet for our users to collaborate with their partners. And that's kind of our global view to where users in any of those regions would consume, or they would find that information in their region, but if they're looking for more centralized information, they could go to Redmond. All the data itself is single instance. There's no replication amongst these regions. So let's talk about capacity planning. In a sense, what we found out is the best thing to do is kind of build a profile for your company. When you build a personal site, what can you kind of expect when, on average, for that site to consume in terms of information? You may have personal storage today, but really it's important to figure out, well, what is that personal site going to be used for? Is it just for finding people that are displaying information, or is it more of a little repository where people can share documents with others? If you've already got a team site deployment, what are your average site sizes? What are your quotas going to be? Kind of figuring out what the profile or the footprint would be for your company. So I kind of gave you a couple numbers in terms of what we're doing inside of Microsoft is across all the team sites we're hosting, and we do have self-service site provisioning, so anybody can create a team site. Same with the personal site. Anybody can create one. They only get one. But that way they can store information they want to share with other people outside of a team context. So if you're searching for me, you can find different white papers I published or different PowerPoints, that kind of thing. Now, one of the key things we found when we were actually scaling this out was really some of the limits that you actually can control are how many sites you actually put in a content database. And what that actually results in is how your databases grow. So we found early on the product group telling us, well, you're going to want to grow those databases fairly large. And we were thinking when they said large, they were saying about 300 gig in size. So we were planning our drives to be, which were on SANs, to be about 300 gigs in size. Our databases started to grow, and we noticed that when we had to restore any of those databases, we were really having a hard time, just in terms of the time it took to restore from tape or restoring to disk and bringing it online, that time it was taking to do any restores was really painful. And we kind of found that there was a best practice where if we had smaller databases, we didn't want really small because then we'd end up with a ton of them, but somewhere between 25 and 50 gig was really the sweet spot for us, where we could easily back them up, easily restore them within a support day. One of our support guys could easily get one of these things off tape and restore it and have it online and get the file back to somebody or a site back to somebody if needed. And so some of the keys there were planning the data LUN sizes, the drives, and what those backup drives would look like. Now those of you who are kind of new to this, or you're trying to figure out, well, what are the right topologies in a sense? SharePoint has a few different topologies they support, and they have their pros and cons. So starting with the small farm, that's really the small business kind of scenario, or a test environment or dev environment where you can put everything all in the same box, or you can separate SQL so you can scale a little bit further. But really it's the target, and I'm putting these numbers together, but it's somewhere less than 10,000, but really realistically it's for people who have less than 3,000 users that are consuming from that one box. And the reason you might deploy one of those is if you're really worried about cost, or if availability like failover and so forth is really not that much of a requirement. The small farm is definitely the easiest to deploy and the cheapest. Now the medium farm, which is basically 2 web front ends and offloaded indexing and job services, gives you more horsepower on the indexing side, as well as it gives you this ability to do failover and load balancing your users. So you can support more users. As well, you can now take that CPU off of those web servers to do your indexing, so when indexing is happening in other environments, it doesn't impact your users. And on the large farm, you're offloading search, you're offloading indexing, you may be indexing millions of documents, and really I think that's kind of the key scenario is the amount of indexing you're doing, because really with your large farm, you've still got 2 web front ends. You can add additional front ends, and my kind of number I'm throwing out there is about 25,000 users per front end that you're adding on is kind of a rule of thumb that we've found for when we add an additional front end web server. So watching your concurrency, and it's not really 25,000 concurrent users I'm talking about. It's really the total number of users that are using this, at least can use it. And we'll get into some real numbers in terms of what's going on at Microsoft. So when you're actually sizing these systems and you're trying to purchase systems, you're like, well, how much memory do I need? Should I care about the network configuration? What about the CPU and the memory? All these different things you can worry about. Nobody's telling me how many gigs of memory do I need. Nobody's telling me, is it a 2 gigahertz or 3 gigahertz machine, or do I need 2 procs, 4 procs, 8 procs? How many procs do I need? Well, I'm telling you right here that for a web server, the things you should be concerned about and the things you should take into consideration are memory and your network. And why I say memory is it's basically those worker processes that when they're pumping out that information, it's memory that they're consuming. The first bottleneck we saw on our web servers when we first deployed was those worker processes consuming memory. It was them hitting it, and then we're running out of virtual memory on our machines. Now, there's some later tuning around those worker processes that I'm going to give you, but in a sense, memory is definitely an important thing for your web servers. Search, it's your NIC. All that search server is doing is taking incoming traffic, the index server is propagating indexes to that search server, and the better the throughput is there, the better and happier that search server is going to be. Now on the index box, this is your crawl machine. It's your job server. It's doing the imports. It's doing the crawler. It's sending out multiple threads. We found it's the CPU on the index box that's really its bottleneck. So I mean, if you're running all these things on one machine, you're basically going to have to be concerned about all these different items. But in terms of processing, that index server is really where your processing is. And the reason I say NIC is it's going out across the network, and it's pulling in information as it's crawling. The SQL server, the key thing for it, again, is its memory, actually. When you're doing uploads, all that information goes right in memory, and then it's written as the transaction logs are run. We found that when we're running large numbers of databases, it's the memory that's definitely the first to go. CPU, it's MS SQL that's like full-text search when you're running Windows SharePoint Services databases. If you're getting lots of data in there, you really got to watch MS Search. That's kind of your key one to watch. That process itself can get out of control, and you need to watch that process in terms of how much CPU it's taking. And I've got a tip later on for you in terms of some ways you can actually utilize SPS search for your FTS stuff, so you can actually eliminate the need for that. And then again on the SQL side, if you've got a really good backup strategy, that's really going to be your biggest player in terms of your SQL Server. All your data is on that SQL box. How are you going to get that data off? Is it going to go onto tape? Are you doing some kind of disk-to-disk backup? How are you getting that data off? And really that kind of plays into that NIC scenario. If it's going to hit your NIC, is that happening off hours when the NIC network card is not utilized? That's kind of the key thing with SQL. Now moving on to give you some kind of realistic in terms of what's going on with the Microsoft environment. This is kind of the full-blown slide that shows the Microsoft farms. And let me describe what's going on here. So MS Web, our corporate portal that I referred to, is that big purple box. We've got 4 web front ends, and that little blue one is what we call our target server. So we've got 3 index boxes on the back end, and each of those index boxes have a host file that refer to that target server. What they do is they'll index against that server, which is then pointing against SQL to index the information. So that way it doesn't impact the end users. So for example, on MS Web, there's 40,000 plus personal sites on that farm. When it's indexing all that information, as well as the information in the areas and so forth on the portal, we don't want that to impact the users. And if that runs into daylight hours when users are on there, we definitely don't want that impacting them. We have 2 load balanced search servers. It's SharePoint that's load balancing those. And then kind of moving across, well actually moving down there, we have a SQL cluster that is the back end for MS Web. There's about 50 databases in that SQL cluster. The largest databases there are the portal site database, those other content databases. We've got over 100,000 items in the profile database, large number of services in that serve database, like the alerts and so forth. And then moving right, we've got 2 web front ends where it says Portal 100. That's the first hosted 100 portals. And what we've done is we have these child portals that consume shared services from MS Web. They share that config database. They're pointing to that config database for where their search servers are. So the indexing, all that search services is kind of utilized by that farm as well. And on the back end of those 2 web farms that are kind of consuming shared services, on the back end we have a 32-bit SQL system, which has close to 300 databases. And then we have a 64-bit system. And the reason why we have both of those there is it's kind of our side-by-side, us looking at those systems to kind of see how the memory is scaling, how CPU is doing. And as the new products are released, we can take advantage and see what's going on between those 2 systems. Now in each of these SQL clusters, it is an active-passive configuration, but that passive node is still used. We're actually pivoting our data resources, the backup drives, we're pivoting those over to the passive node, so when they're backed up to tape, It's the resources on that passive node that are actually used to back up the tape. So if backups are actually happening during the day, it doesn't matter because it's on that passive node. Now they can be used for failover as well. So we've got the failover that's built in. We can use either one for backup. But primarily we'll do like this one's the primary and this one's the secondary in terms of our SQL cluster, so it's easier for the support people. So they know kind of which server the resources should be on. But those backup resources kind of pivot back and forth based on the time of the day and based on what's actually happening. Is it SQL that's backing up? Then they're on the active node. If it's going from disk to tape, then it's on the passive node. Now on the Windows SharePoint Services side of the house, and this was kind of a decision that we made early on, was actually to have separate farms so that we could kind of utilize a single namespace, or reduce number of namespaces. Was we built this team farm. It's a single virtual server with the name of team, an inclusion path called sites, and then 10,000 plus site collections that hang off of that one. That's our primary virtual server. Any Windows SharePoint Services sites that are created inside of Microsoft in North and South America are actually created against that team farm. And it's about 1.5 terabytes of data now in the databases on that SQL cluster. And team itself, we've actually split across those two SQL clusters. So it has about 50 databases split across those two SQL clusters. The host header farm is a different deployment of Windows SharePoint Services, where we're actually using a wildcard and using WINS and DNS to actually, or WINS in a sense for our internal environment, for hosting host header sites. So it's a single name site, a vanity URL on that farm. And then that final Windows SharePoint Services farm is our upgraded farm. We took our 11 SharePoint servers that were in North and South America, our SharePoint Team Services sites, and we upgraded all the virtual servers and put them in this one farm. And that one it's got over 500 gigs. But the key kind of interesting thing with that farm is it's got 50 virtual servers, IIS virtual servers running on it. So it's not the best deployment, but what we plan to do over time is to kind of consolidate those virtual servers down and to kind of clean them up. And that's kind of what's taking place in the Windows SharePoint Services environment itself. Is we're consolidating the information into databases. We're splitting those databases into 25 gig increments, and everything's scaling extremely well. So let's talk about scale. One of the things that we've done inside of Microsoft is, and I think it's one of the coolest products, is SQL reporting services. And so what we've done is we've taken our configuration database and some of the information in some of the site databases, the content databases, and created a little DTS package so we can point SQL reporting services against it. So we've got a breakdown per region, how many databases, how many sites, how many virtual servers, how many databases, and as well it kind of gives us the ability to drill down to look at a given database to see how many sites it has and so forth. Kind of gives you a view of how much information is actually in those databases. So I referred to the team virtual server, which is our largest one, and just kind of giving you a view across that. So 1 week in January, we had 24 million hits, and what was transferred during that week was 1 terabyte of data. A large portion of that was actually going to the index box, but it kind of gives you a view of those 80,000 unique users during that week on a SharePoint environment. Now you may be wondering, well, what do the systems actually look like? Well, here's a week in January, that top box, where you can see that the CPU on those web servers, really not too bad, somewhere between 20 and 40 at peak. So CPU really wasn't a major factor. And then if you look at the connections, with the team farm, we've got 2 dedicated web front ends that are load balanced. Almost always primarily both in the mix, taking traffic. That third box is actually used as a target box for indexing. So you can kind of see that bottom blue line is the index, the target of the index box. So indexing the team farm, the terabyte and a half plus databases. And now MS Web, our central portal, quick view of what it's been seeing. So they're looking at their monthly unique users and the search requests across those months. So we're seeing 30,000 plus search requests a month, with pretty much 2/3 to 3/4 of the company hitting MS Web, our corporate portal, once a month. As well, all of our personal sites that hang off of MS Web would as well be included in that traffic. And one of the kind of primarily new things that MS Web has been doing over the last couple of years is pulling in web feeds and pulling in news feeds and pushing that information out to the users. And you kind of see the news and alert subscriptions that are actually being pushed out from that central portal. So now we've got over 60,000 alerts and subscriptions that are actually taking place from news feeds based on our corporate portal. Now, kind of stepping back and looking at manageability and how we kind of monitor this environment, we're using Microsoft Operations Manager 2005. And it isn't just one MOM pack that we're actually looking at here. Starting with Windows and then adding on the applications on top of it, Windows SharePoint Services, SharePoint Portal Server, and SQL, and IIS, we kind of found that the one that gives us the best availability in terms of is it up, is it down, is actually IIS. So IIS is actually telling us, yep, on those web servers, that application pool is disabled or it's unhealthy. Windows SharePoint Services may tell you about either the antivirus has been loaded, or it'll tell you your content database is getting near full. You've hit your alert notification level. Portal Server will tell you about propagations of your indexes. It'll tell you about some cache getting corrupted. But primarily, if it's up or down, it's IIS. It's kind of telling you very critical events. But those nice SharePoint application packs will kind of tell you the health of what it can in terms of what's going on with SharePoint. SQL is a great MOM pack. Tells you about the blocking or databases that are full based on how you're scaling those databases. And it'll kind of tell you about critical events. Cluster service has actually been pretty quiet. I think we've only had like one problem with the cluster, and it was more of a resource problem. But those are packs that you can install. Now let's drill into performance tuning. So now that you've got these environments, what are some things you can kind of do to optimize or to continue to plan out your environments? We've kind of found some key performance indicators around the memory, around the processor. I mentioned the MS search process on the SQL Server. Well, the key one on the web server is the W3WP. It's those worker processes. Watching the memory on those, watching the processor on those processes. Looking at your network, looking at the queue length on the network so you can kind of see, are things actually queuing up, trying to go out onto the network? We kind of use the current connections to kind of give us an idea of the load factor on the web servers. There's no magic number in terms of, if you have so many hundred current connections on your web server, that's, then it's dead, or then it's not accepting connections. The SQL Server, we like to look at the login, log-offs. We look at the user connections, the pooled connections, anywhere where we can kind of look and see if there's any queuing going on, either on the disk, which hasn't been a problem, but looking at memory, the pages per second, see if it's paging, available memory on the systems. But usually it is a virtual memory on the worker processes, or the MTL memory, which there isn't a perf counter for inside of SQL. So looking at the application pools and how we can actually performance tune IIS, some of the kind of key things are when you're planning these systems out to use few virtual servers. The fewer you have, the easier it's going to be to manage. As well, when you're actually doing performance tuning, when you have few virtual servers, then it's easier to kind of know where, when you're narrowing down where the problems might be encountered, you're looking at few virtual servers versus looking at 100 virtual servers, trying to say which of these in which app pool is spinning up too much virtual memory, for example. One of the kind of best practices there is to consolidate when you have large numbers of app pools. Kind of a rule of thumb is no more than, you definitely don't want to do more than 10. Kind of a good number of application pools is somewhere around 3 or 4. But the ideal number, if you've got one virtual server, is to have your admin app pool and then to have a second app pool, one for your virtual server. Then what you can do with that virtual server is to create a web garden. And what a web garden is it allows you to create multiple worker processes for that one virtual server. So we'll see a screenshot in a second on how that works. What you can do then is limit the worker process memory on that application pool in the application pool settings. So you can say the maximum amount of virtual memory I want this worker process to consume is 500 or up to 800, kind of based on what you've seen in your environment in terms of when that worker process starts to become a problem. What you can do is you set that in place before it becomes a problem. It can then recycle it, spin it up again, and clear out that memory. Oh, and the last item there was, in a sense, there's this feature in IIS which is great for some circumstances, and it may work for you in your environment, but I've found that the auto rapid failure gives me problems. If an application cycles too many times within a certain amount of time, and you can control all those variables, it'll automatically disable it. Well, if you've got a single virtual server that you've really scaled out, and the app pool gets disabled, nobody's getting in there. It's shut down. It's not coming back until somebody goes in there and starts it back up. So if you've got lots of virtual servers or lots of application pools, then this feature is great because it can say this virtual server, this app pool is run amok, and I'm going to disable that one. But I've found in the SharePoint farms that's actually more uncommon than common, where you'd have certain app pools that are a problem and the rest of them are good. So I referred to some screenshots. On the application pool itself, you can look at the properties. And looking at that first tab, the recycling tab, right at the bottom is where you can limit the amount of virtual memory. And then looking on the next tab, on the performance tab, that's where you can, by default, you've got one worker process for your application pool. So if you've got very few application pools, you can actually increase the number of processes for that application pool. And why you would do that is it spreads the amount of the horsepower behind that app pool. You can spin up 2 or 3 processes. Kind of gives you that multi-threading ability for that one worker process, or for the one app pool. Then looking at the Health tab, what I've found is when I've got a really large virtual server that's doing a lot of work, that default startup time limit is way too short. I'll look in my event logs and I'll see that it couldn't start up in time, or it couldn't shut down in time. And by giving it a higher limit, it actually gives it more time to start up without it calling it a problem. So that might be one way of kind of giving IIS a little bit more time before it starts to cripple itself. So in a sense, the worst case scenario is this out-of-the-box feature of you've got the You've got the application pool health monitoring turned on. And then you've got a short startup limit. So it tries to start up 5 times. Boom, now it's disabled because it couldn't start up in time. Now let's kind of switch gears into SQL. One of the things you can kind of do is start off with a really good maintenance plan. Now working with your SQL folks, or if it's your team that's doing this, it's how often do you need to do database consistency checks? How often do you need to be doing defragmenting your disks or your databases? Is that some kind of plan to come up with where you're actually cleaning up the databases, cleaning out sites that are no longer used, pulling out information that isn't relevant anymore, and kind of keeping a maintenance of those databases, kind of building a plan that you can execute on. And then looking at the resources, looking at full text search on that SQL box. Is it consuming lots of resources, or is it a problem? Are users complaining about stale search on your Windows SharePoint Services servers? If that's the case, you may want to look at SPS search. There's a great resource in MSDN now, someone just recently published, where they've actually utilized a little control for doing search against your Windows SharePoint Services sites using SPS search. So it does require you to be running SPS, the portal server product, to get that, but it's something we're actually doing in our lab right now to kind of extend search so that we can eliminate our need for FTS, or full text search, on our SQL box. Offload some of that processing that's going on and doing double indexing in a sense. Now if you're talking about, well, how many instances of SQL should I be planning? We've kind of found that for maximum performance, 1 per server is kind of the rule of thumb, unless you're finding that you're running multiple apps on that SQL box and you need it for security purposes. So it's a great way for kind of partitioning them, but if you don't need to, you'll find it's much easier to run with 1 instance of SQL, kind of a default instance. If you're running a cluster and you're doing an active, passive cluster, you're going to need at least 2 instances, but what you can do is you can kind of have 1 primary for that resource group and the other one be primary for the other resource group. And then looking at optimization, or kind of in a sense even planning, looking at your RAID configuration. If you're trying to figure out how can I make these databases be the most performant, you're probably going to be looking at a RAID 0+1 for your transaction logs, and you may want to debate whether you're doing 0+1 on your data for your databases, or if you're doing RAID 5. So depending on your disk speeds and your tolerance, you can kind of weigh out how you're optimizing your information. Now looking at memory, I kind of mentioned that memory was very important on the web server and on the SQL server. We found that the kind of best footprint for Windows 32-bit server is 4 gigs of RAM. So what we do is we run the 3 gig switch in the boot INI, which allocates 1 gig for the OS and 3 gigs for the application. So that way our worker processes can use, all that stuff is addressable, all that 3 gigs is addressable for IIS and its worker processes, or other applications in a sense that are running on the web server. On the SQL side, you've got a couple of different options. You can go with 4 gigs of RAM, add the 3 gig switch. Inside of SQL itself, there's a SQL startup parameter, -G512, which allows you to add so much memory, and 512 is just kind of the one I'm giving out there. But 512 would give you 512 megs of RAM for the MTL space. It's the mem to leave space, which is primarily where we found SQL to be the bottleneck in terms of trying to upload large files into SharePoint. It uses MTL for that, that process. And if you're looking to find more addressable memory, it's using AWE and PAE in your startup parameters. and as well on SQL, the AWE piece. PAE is for your boot INI. A couple of different options for machines that are running more than 4 gigs, like 8 gigs and upwards. But in a sense, we've kind of found the easiest is actually running with the 4 gigs of RAM, and then increasing our MTL space with the -G switch. The kind of key thing for us was making sure that we don't allow more than 300 databases per SQL instance, and an instance being on a SQL server. So, and even that 300, it would be my preference to actually stay away from that by like saying, okay, no more, let's do 100 database or let's do 150, but kind of trying to stay away from 300, because 300 is where you'll start to experience memory problems on your SQL server. Another reason why we're actually doing the 64-bit servers is memory is really a key thing for how we can address more memory, and SQL can then be kind of freed up to do more. Backups was definitely one of the things that kind of stressed our systems out. Early on, we were doing site backups to try and back up all our information to make it really easy to restore. We found that site backups really just don't scale so well. And while they're running, they can actually cause SQL blocking. While it's backing up, it's going to try and consume all sorts of resources on SQL. One of the nice little things that you may be aware of is there's a SharePoint Database Explorer. So if you can get that database back online, there's a resource kit tool that allows you to pull the file out without having to have some kind of standby system, or without having to join that content database into an existing farm. One of the things we've done around backups was we're actually using a third-party tool. It's called SQL Lightspeed. But what it did is it basically allowed us to compress our backups during backup. So it actually increased the speed. We were able to back it up about close to half the time in terms of how quickly we can back up the data. And then as well, what we actually got on disk was a lot smaller as well. It actually compressed our data down to about 75% of its original size. And then we would back that up onto tape. So we were reducing our time it was actually taking us. At one point, to back up our close to 2 terabytes of data, it was taking upwards of 16 hours to back up the data. And it was just a real problem before we were doing this pivoting, doing these compressed backups. Now we found we can continue to scale out by using some of these tips or some of these tricks. Other options, I know there's networks that set up this private network. We're using a fiber attached tape on our passive node, so that way it's not even hitting a network. And then, like I mentioned before, this pivoting using our passive node for backups, utilizing those resources instead of the primary resources on our primary node, our active node. And with SPS backup, you can use it to back up your whole application. We've kind of found if we use SPS backup, the primary thing to be backing up is our indexes. The SPS backup is great for backing up the index because the index really can't be backed up any other way natively. There are third-party products that you can use to back up your index. On the network side, I kind of mentioned some of these things in terms of helping out backups, but really you can use them to help out in terms of getting that traffic off the network as well. One of the tricks is really configuring how you're configuring your web server traffic. You could set it up so that one of your NICs is kind of your front-end traffic that takes your user connections. Then you have this back-end NIC or a second NIC which communicates to the SQL server. So you got inbound traffic on one and outbound traffic on the other. We found that's great for performance and kind of optimizing the network, but it's fairly difficult for our support guys to really understand when they're looking at static routes or they're looking at separate VLANs. The network guys kind of had a hard time with us when we said, well, we have a requirement where we want the front-end NIC on this certain VLAN, the back-end NIC on this certain VLAN, and it was kind of a data space data center space consolidation kind of scenario where they had to be in a certain area of the data center to be able to be in that configuration. So that's one option. With static routes, you could kind of get around some of that. But that's definitely an option that you could use to optimize your traffic using. There's also NIC teaming, which is something we're not using. The one we are using, and the one that we've kind of found, we kind of use this one primarily, is using just a simple crossover cable, or like a simple hub or switch for doing our NLB cluster. So when we're doing our Windows load balancing, it's basically a couple of web servers, little crossover cable between the two. And when we've got more than two, then there's going to be some kind of switch between the three boxes. What we'll do is set up some kind of private IP between the three on some network that isn't addressable for that network. And then as well on our SQL clusters, basically having some kind of cable where we can do communication between the nodes in the cluster. And when we first deployed, everything was 100 megabit. When we deployed GigE, it really made network not much of a factor. It actually increased our performance around three times the performance when we went to GigE. Really helped us out in terms of being able to optimize the traffic on the network. In fact, when we were running backups over the network, we were seeing all sorts of bottlenecks. We implemented GigE, and then all of a sudden it was no longer a problem. We knew that we were going to run into that again, which is why we went some of those other routes for getting it actually off the network. On the indexing side, on the SharePoint portal server, in terms of planning this out, there's a couple of resources that you can use. The site directory is a great resource for kind of putting all the sites, all the SharePoint sites in there that are kind of important to be indexed. Putting them in a site directory, using that as the content source, made it really kind of easy to get search scopes built. So when you want to search across data, boom, we point a content source against the site directory. We create a source. We create source groups based on the metadata, and then when in the drop-down we can kind of choose how to build our source, all the scopes for searching. And what's a couple of the keys were really around the number of indexes. When you have a lot of indexes, it becomes very complicated. Relevancy becomes very difficult to manage. It's difficult to not index things multiple times. So by having very few indexes, it makes it much easier. A couple of key things: ad hoc content, putting those in the large index. That way, and then putting your important content in the smaller index. Basically, the relevancy is weighed out based on the size of the index. If everything's exactly the same size, then your relevancy is going to be pretty good. But by putting those ad hoc kind of created sites where people are just creating things on the fly, it may not be business critical or official sites. Putting those in a large index made the relevancy so that it was kind of less important. In terms of maintenance, watch those iFilters you're adding on to your index server. So if you're trying to index PDFs, if you're trying to index faxed content or AutoCAD files, a lot of those iFilters are single-threaded. So I definitely recommend kind of watching the indexing itself, because what we found is it's very easy for search to go into single-threaded mode and then to not come out of single-threaded mode. So SharePoint is built to be multi-threaded and to use all sorts of threads. You can actually control the number of threads. And that's actually kind of one of the best practices as well, is actually limiting the number of indexing threads if you're seeing performance problems based on the indexing going out and hitting a farm. So for example, Team, when it's being indexed by MS Web, we really have to be careful about how many threads are hitting the Team farm, because it can impact the database. There is a default little job that will index every 10 minutes. There's been more than once that we've kind of been bit when we've like rebuilt a job server or something, and in comes this index every 10 minutes on the portal. So that's definitely something you can easily remove and kind of put into place what your plan is for indexing the enterprise. Some kind of miscellaneous things to kind of think about. Kerberos, there is a new KB on Microsoft.com for setting up your Windows SharePoint Services boxes to run Kerberos. Recommend kind of looking at that one. NTLM versus basic. You can kind of look at all these different IIS supported methods and weigh out what works for your environment. I've seen some blogging around IIS compression. We started looking at doing some IIS compression. Found some recommendations. We were running level 9 and doing some dynamic compression on our ASPX pages. And we did find that at face value, we didn't even notice any difference in terms of browsing. But when we look at the network, we did notice that, hey, those packets are actually going across compressed. And the users didn't even notice it was compressed. So we'd like one front end, we turn on IIS compression. The other front end, no compression. And users didn't even notice, and no complaints. It does require some CPU, so kind of just something to test out and see if it actually helps you with your bandwidth consumption. As well, there are actually some great third parties that are doing some work around the network performance. Offline scenarios. Iora, for example, has a replication scenario. There's now some acceleration devices that I've heard about. So there's some other things to explore around third parties that may help you out in the network area in terms of offline scenarios or getting to over slow links and that kind of thing. Definitely would recommend installing SP1 on Windows SharePoint Services and SharePoint Portal Server. There are some performance fixes. One of the fixes that I'm even calling out in the bottom there will really help you out with performance. The SharePoint usage and site backup, there's a KB article on it, a little post SP1 hotfix for Windows SharePoint Services. What that really does is we found that when if usage analysis is turned on for a site, it'll actually flip the last modified date. And the crawler, when it comes, it's going to say, oh, this site's changed. I need to index it. Now, it looks through all the lists to determine that it doesn't need to, but that didn't even need to take place if they hadn't have actually flipped the date showing that, oh, it's the same content as it was before. So that's one that you can actually find will help you out a little bit. You may not notice it much, but it does make your last modified date stay or won't move as usage analysis is changing. I already mentioned SPS search versus full text search as an area to explore in terms of kind of removing FTS as a dependency for Windows SharePoint Services if you're running SharePoint Portal Server. What's coming up? FY06. So 64-bit, I already kind of talked about that. We're really exploring that. Windows 2003 SP1. We're rolling that out across a number of the systems. SCW is a security configuration wizard, which allows you to lock down your systems. It's kind of like the equivalent of Service Pack 2 for XP, where you can kind of lock things down, kind of like the firewall for your client. Well, there's a configuration wizard that will allow you to kind of lock down your server. And we did some early testing on that. Now it's released, and there's a lot of great features there. SQL 2005 is just around the corner. We're looking at that and kind of looking to the product group as well to let us know when they're supporting it. There's SharePoint SP2. We're actually doing some early testing on that inside of IT. Can't really talk much about that, but we're continuing to scale up. It's a large environment, but we're not even saying that our team URL, that virtual server, we're not even saying that it has hit any kind of limit. We expect to be running, the kind of cool thing with that virtual server is we've been running that one since beta 1 of Windows SharePoint Services. And we're still running on that one virtual server, and we'll continue to run on that virtual server probably until v3, and then we'll just upgrade that one. And in a sense, there's actually some tools we've been looking at. We've been looking at some third parties. One of the areas that anybody who's kind of wondering about what areas to kind of look at, Recycle Bin, in terms of performance, is probably going to be an important one for you. We're looking at a Recycle Bin that's actually in our lab right now that will capture delete events so that we can, what it'll do is it'll actually write them to the file system so we can restore files. As soon as we've actually tested that tool and pushed it out to production, we'll put our scripts and tools up on got.net so anybody can take advantage of that if they're interested. There are some third-party solutions around the Recycle Bin type functionality for restores. So you may want to look at those as well. Search and indexing optimization. I don't know if I mentioned, we're actually indexing over 6 million documents now. And over the next couple months, we plan to open the gates even wider, where we'll be indexing about 10 million documents across the enterprise. So ranking and optimization is definitely continues to be important for us, and we are working with the search team and with PSS to optimize it and to help push out hot fixes and anything that we can do to optimize the searching and indexing that's going on. So let me give you my references, some things I referred to today. That top link, the IT Performance White Paper, was one that was based on an interview where the technical writer basically interviewed me based on our environment. It's got a lot of the perf counters. It's got a lot of information about our environment and kind of delves into the other areas that I may not have focused on here. There's a deployment webcast if you're kind of interested in our services how we deployed our services. There's a great white paper the product group put out around running SharePoint and ISA. The resource kit is a great book, and there's a number of chapters that are online now. And TechNet, of course. So let me summarize. Establishing a profile for your company and kind of planning out the database capacity. Namespace strategy. I kind of went over and over again about the IS virtual servers. You can keep those numbers few, and it's really going to be your namespace strategy that will probably drive your virtual server or IS virtual server strategy, those websites. Enterprise search. Plan ahead for how you're going to be indexing the content inside your company so that you can avoid duplicate indexing or having other environments indexing the same information you're indexing. And monitoring the performance. There are bottlenecks out there, but if you monitor for them, there are plenty of workarounds for addressing those. And there are showcase resources, more white papers around other products that IT has put out. Recommend checking out those links as well. And let me hand it back over to Jason.
All right, thanks. Okay, just really quickly, I've got a couple of slides I want to get through, and then we'll go into questions. This slide here is a few ways to dive a little bit deeper into what TechNet offers. If you're not familiar with TechNet, you've actually been watching the TechNet webcast for the last hour or so. These are a few URLs just to kind of get you started if you're interested in signing up for, say, the Flash newsletter or security notification service, or you just want to check out some more of the TechNet webcasts. That's probably where you got started signing up for today's event, but if you want to check out some of the archives, that's also a good place to go. Microsoft.com/webcast. You can see that right there. Then there's also, down at the bottom, there's a contest we've got going on. If you'll stick around for just a few minutes and fill out the evaluation, you're entered to win a 1-year TechNet Plus subscription or TechNet Plus renewal. This is a $500 value, so it's a huge contest, and we give away one of these each event. We're also giving away Creative Zen portable media centers, 10 of those a month across the webcast program. And again, all you have to do is fill out the evaluation that I have coming up here in just a moment. I also wanted to mention here the link. If you've got content ideas, you got something you'd love to see us cover on TechNet, this link here will get you a kind of an inside link to our marketing manager, our events programmers, the folks who plan these events. It goes to all of our production teams. So this is a link that you would use to send us feedback, send us problems with say your audio, or not your audio, but getting your post-event resources. It's a great link to get right at our production team. And it's actually the same link as if you went to any of the event pages and clicked on the Contact Us link at the very bottom of the page. If that's a little hard to remember, you can always choose Print to PDF up in the File menu, and we'll give you the option to save it as a PDF, and then you can grab that URL. And then down there at the bottom, if you're starting to think about web conferencing or your organization is, right now Live Meeting's doing a free 14-day trial, Microsoft.com/presentlive. You can check that out there. I wanted to do a quick poll, see how folks were able to hear us today. If you had a perfect, pristine experience, we want to know that. But if you had some problems connecting to the player, or you needed to dial in and listen via phone, maybe the volume was too low, what have you, we want to know that. So please take a second, fill that out. As a reminder, as always, if you ever have any problems with audio, if you have less than a perfect audio experience, you can always connect, you can always change your seat color to red, or put a comment into the Q&A pane. I'm monitoring that throughout the event and can hand you a phone number so you can dial in and listen via phone. If that's not an option, I can try to help you troubleshoot. I know in a lot of cases it's kind of limited what I can do because I know that a lot of folks come in with odd clients or strange configurations or say are missing speakers. So we'll do what we can to kind of get you a much better audio experience. So thanks for that feedback. I'm going to put up the evaluation slide now. You should see this pop in that slide area. This is actually a web page, so all the links on here are hot. Click on the registered online link about midway down that page. It'll confirm your registration information, and then there'll be a series of questions, first about product interest, but then the ones we're really interested in here are, what did you think of today's content? It's important we get this feedback to Joel as well as our event team, and make sure that we're iterating on things that you want to see covered in these events. There's even there's a comment box for specific comments. So if there were things that you really wanted us to cover today, or that you were really glad that we covered, that's a great place to put them. With that, I believe we've got about 6 or 7 questions in the queue, so I'll just hand back to Joel for the questions. Joel?
Great. So I'm looking at the questions now. What I'll do is I'll read the question and then I'll just answer it. So the first question was, am I talking about SharePoint 2001 or 2003? So throughout the presentation, I was talking about, when I talk about SharePoint, it's SharePoint Portal Server 2003 and Windows SharePoint Services, which is the latest release. The next question is, how do you centrally index efficiently across the regions? Doesn't the SPS search add-on from MSDN require changes to the site def? Wouldn't this be unsupported if the out-of-the-box site definitions are changed? So let me answer the first question, which is about centrally indexing the regions. So for example, what we're doing in the regions themselves is they do have search servers. There's a shared services environment in the region, and they're indexing locally for, say, Europe. All the data in Europe, Middle East, Africa is on those index servers for local indexing. What we're doing at MS Web for the centralized or the central indexing from MS Web, our central portal, it indexes the globe. So there is a second indexing of the content that's in those regions. Not the most efficient, I agree, but it does give us the global search as well as they have results locally, so there's no latency between doing searches that are within the region. The second question was about that SPS search component that I talked about. There are a couple of different ways to do this. There's a TechNet or MSDN article about a little web control that you can do. I've seen people that what they'll do is they'll just change the little form so that it posts against the search. And but it is kind of a great question to say, is it supported? And if you do have any questions about support, you could talk to PSS or your account manager about supporting any changes. So, for example, you can make copies of those pages and then roll back if you need to. But I would definitely recommend talking to PSS before you make anything that might not be supported. Is there any way to increase the number of calculated fields to list more than 8? I'm not sure. That's a great question, but I'm not sure about that, the answer to that one. Are there statistics coming to, are these statistics coming from reporting services template? So this one that I just displayed is one that we built ourselves. I have seen a beta of a reporting services template. I can't really talk about it because I'm not sure what's been shared, but from what I understand, there are good things coming. So if you liked that idea of being able to feed data about your environment, that there might be something coming for you there. I have a SQL server. Can I use the same SQL server to host databases for SharePoint, or do I need to buy additional licenses? So I can't necessarily address the licensing question since I'm not an expert on that side, but you can definitely utilize an existing SQL server if you've got one. In fact, in our environment, our project server actually utilizes one of those SQL clusters that we're utilizing for our team sites. So sharing them across different apps, SharePoint kind of uses SQL, just pure SQL. You're just connecting to those databases. It doesn't have to be, SA, for example. You can actually limit its rights, or it could be a different instance than another application on that same SQL box. Is the number of worker processes that you're running related to available memory? And the answer to that so far is yes. It depends on how much memory you're putting on your system, definitely. So if you have a SharePoint application with a set of web parts putting a lot of data in an ASP.NET cache, such that it is running over 800 meg, let's say it's around 1 gig, with 4 gigs of RAM and a 3 gig switch, you really don't have enough memory for a second worker process. Is that true? So it is kind of specific based on your environment. But let's say that you do have a worker process that it is running around 1 gig, and that's kind of normal. You could have another process and be running, let's say, 2 that are at 2 gigs, 2 that are at 1 gig each. But you're going to have to kind of see if that works on your system. For us, it was how can we'd actually see these worker processes that would kind of spin out, and then they would kind of hang. If they're going up and you want to cycle them, you can set that up so that they'll cycle before they run out of memory. As well, you can spread across the processing for a given application pool to consume more resources if it needs more horsepower. So the next question is, how do you do recycle bin now? So today we don't have a recycle bin. The way that we do restores is we plan our databases so that they're about 25 gig, And if we need to restore, we've got a local copy of last night's backup where we will restore, we'll bring that database online in a restore SQL server, and then use the Database Explorer to pull out a file, or to, if it's a site or something like that, we can connect it up to a box to pull out the site. So we don't have a recycle bin today, but we do have a restore process. And that's it. Thanks a lot, everybody, for attending. I appreciate your feedback. And thanks a lot, and good luck with your SharePoint environments.
All right. Well, thanks to Joel Olson for coming in today and presenting on SharePoint. Oops, turned on my speakers there. Thanks to Joel for coming out today and speaking on SharePoint performance capacity planning. And thanks to all you folks for coming out and having a listen. Again, this will be archived in about 24 hours, so you can go and check that out. I also wanted to mention to the user who's having a problem with the survey, I'll be posting a link to the survey in just a second to you, so you can post it into your IE browser or otherwise. Thanks again. We look forward to seeing you on a future event, and have a great week.